Well, hello guys. So in today's video we are going to study about processors, also known as the CPU. So you might have heard about the term processor or CPU at once in your life. Maybe when you go to purchase a laptop, they will ask you which type of processor you want. And not only in computers but in many of the devices, processors play a great role. So let's learn about them. So you go to a shop to purchase a PC. You see two PC with same looks, but one has 64-bit i3 3rd generation and the second one has 64-bit i5 4th generation. But what the heck this I means, and what's this 64-bit and the generation? We will look at these terms later in a video, but first let's know a little about processors. So what basically is a processor? It is heart and brain of a computer. A processor is simple, a primary component of a computer designed to move and process data. The performance of a computer is based upon simple mathematical operation, and the CPU is the device that controls all those operations. It has four primary functions: fetch, decode, execute, and write back. Fetch is each instruction is stored in the memory and the processor gets it from the memory. The decodes, it decodes the instruction. Execute, the ALU part execute the instruction, and store, the store part is where the instruction is gets stored after it is being executed. Now let's learn about different components of a CPU. The first is the control unit. The control unit uses electrical signals to instruct the whole computer system for carrying out or executing program instruction. Its name clearly shows that it controls and coordinates computer components. It tracks instruction from memory, the decodes and execute them. In short, we can say that these components receive, decodes, stores, results and manages execution of data. The next is ALU. It executes all arithmetic and logical operations like addition, calculation, multiplication, division, comparison, etc. ALU can also be used for different purposes of maintaining timers. The last is register. Register are storage areas that are responsible for holding the data that is to be processed. They can store the instruction and data in a processor. The data is further used by the control unit. They are of greater value and do some specific tasks like the program counter, stack, and blah blah blah. Then comes the main question: how can we compare processor? How to differentiate amongst them? First of all, we go further. Let's know about the two main competitors in the processor market. These are the Intel and the AMD, as you can see on the screen. So which to prefer of the other? Intel processors tend to be on the less expensive side. However, they are best used in budget computers where price matters. Intel on the other hand has more expensive models, which are a bit expensive than the AMD counterparts. Personally, I install AMD processor in computers for people who don't use their computer that often, like they just use the computer for checking the emails, browse the web, edit few documents, etc., which don't require much power. For users that are constantly editing videos, playing 3D games and running a ton of applications all at once, Intel is the way to go. So now comes another factor to compare CPUs, the clock speed and the number of cores. Well, clock speed is how many calculations a processor can crunch in a single second, while cores is how many individual processors combine onto one port. This can be really complicated, so I'll simplify a bit. Imagine you have an old single processor clocking at 1.0 GHz. This is the speed of the processor. And if you get an Intel dual-core i3 clocking at 2.2 GHz, think of it basically as the same as 4.4 GHz total, since there is two cores. So if you think that way, 2.0 GHz quad-core is better than 2.5 GHz dual-core. The core speed is better in the dual-core example, but the overall speed and performance is better in the quad-core model. Now for the technicality, let's say an example that you have 1 GHz dual-core and 2.0 GHz single-core. By the example in the last para, they should be same, but I would rather have the first one because although it's slower, it has multiple cores and is quicker and provide better performance. Cache size is also important, but that's another can of worms. Just know that the bigger the cache, the better, but can be expensive. Now, I have left another example for you to think which type of processor you want to purchase as a consumer. So if you want to know about the performance of your processor, there's a link I provided with this video. The software CPU-Z basically benchmarks all your PC's performance. So just remember about these terms when you go to buy your next processor. Well, thanks for watching this video and don't forget to like, comment and subscribe to our channel for more updates.
Created using Powtoon.